In this video, I'm going to be talking about how to solve rational equations. So in solving rational equations, there is a general strategy, which starts with multiplying to remove fractions, followed by solving using linear/quadratic rules, and then checking that the potential solution is within the domain. So for the example 1, solve the rational equality below, we have 8 over 8x minus 5 plus 1 is equal to 32 over negative 32x plus 20. So to start this question or problem, we're going to reduce this denominator to something that we can multiply to everything in order to make it look a lot easier. So in this case, we can take out a negative 4, and then it leaves us with 8x minus 5. So right here we can see that the 8x minus 5 right here, which will be this, is equal to this right here, which will make our lives 10 times easier when multiplying to remove the fractions. So now after that, we're going to multiply each number or term by negative 4 times 8x minus 5. So and right here, since this is basically the exact same, it's just going to cancel out and leave us with 32. And then same with here as well. These 8x minus 5s are going to cancel each other out and leave us with negative 4 times 8. And then this negative 4 times 8x minus 5 will just become the 1 here. It'll be negative, because it's a negative 4. 8x minus 5. And then equal to 32. So here we can just distribute, and right here we're going to distribute first. And it'll be negative 4 times 8, which is equal to, or plus here, negative 32x plus, basically our original denominator for the last term. And then right here we're going to get negative 32, and then we can just bring it over. Now we just add like terms, so it's actually you're going to subtract 32 from both sides. You have 32x plus 20, negative 32x plus 20 is equal to 0. Move the constant to the other side. Divide both sides by 32. And you will get 20 over 32, which is equal to 5 over 8. Now this solution right here is our potential solution. We don't know if it's our actual solution yet, so in order to do that, we put our potential solution back into the starting function to see if it turns out to be as it says. So down here, I'll draw a line, separate. We're going to have our 8 over 8, and instead of x, we're going to put 5/8 in as our variable, minus 5 plus 1 equal to 32 over negative 32 with 8 5/8 of the x plus 20. So when we distribute the 8, or the numbers to the variables, we're going to have 8 over 8 times 5 is 40, and 40 over 8 is 5, and then 5 minus 5 is 0. And you can continue to distribute these all out to get the entire equation. And then these calculated with this one. Negative 32 times 5 over and negative 20 plus 20 is going to be 0. So now here we can see that both of these are being divided by 0, which is not capable of happening. So we can see that there is no solution to this equation because it will leave us with an error. So then you would just write no. So in this type of problem, we come out with no solution, but in other ones, you would add place the potential solution back into the starting equation, and if it would equal out correctly, then that would be your actual solution, if it's within the domain. But here, it is actually not within domain, because if you go back and you use the denominator to find one of your domains, you'll end up getting our potential